Hi, in this video I will be solving another example with a full details about Kirchhoff rules. So the question asking me to calculate the current through each resistor in the circuit. Once again, I have three resistors with the two batteries. Uh, it's quite similar to the one I solved previously, but just to practice more solving Kirchhoff rules and apply them in a circuit. Now, once again, I can pick a certain junction. I can say, all right, I will pick this junction here, and I will say that will be I1. It's going out, and I will choose I3 as well going out. That means I2 is going in. Now I try to label the current 1, 2, 3 the same name of the resistor 1, 2, 3, just to avoid any confusion. Sometimes you might find people label the current, say it is like current 1 here. In this case, they might say it is current 25. That means the current going through the 25 ohm resistor. Current 2, they will call it current 30, which means it is the current going through the 30 ohm resistor, and so on. All right, it doesn't matter. Now I will choose my loop direction for the top one to be again clockwise. That's loop 1. Okay, for the bottom one I will go with the counterclockwise. I will go loop 2. All right, now again we can help ourselves that the current is going here, I1. Now through this branch here it's I2. For I3 this is the direction. Okay, so this is high voltage, low. Here is the high, here is the low, because the current is going this way. Here is the high and low. If you feel more safe if distributing these positive voltages and negative voltages, why not? You could do that. It's fine. It will help you to master or control your equations writing. So let's write the first formula, or the first rule, the junction rules. I have I2, it's going in, equal I1 plus I3. That's our first equation. Now for loop 1, let's go with loop 1 and starting from here. For loop 1 it will be, right, it is the top loop, the top loop, it will be 45 positive. Now going through the second resistor, that will be negative 30I2, and going up, going through resistor 1, that will be again negative 25I1, and that's our loop done. Alright, let's go to the loop 2. In loop 2, the bottom one, I could start from here. So I'm going through the battery. It's a positive 75, negative 15 I3, going up, and now I'm going in the middle branch where I will be going through the battery 1, and it's positive 45 volt. I'm going through resistor 2 from high voltage to low voltage, that will be 30 I2, and that's it. Now let's just make it more simpler. It is 75 plus 45, that will give me 120, and it is minus 30 I2 minus 15 I3 equals 0. So this one will be the second equation to use, and this is our third equation. Now once again, let's modify these circuits, these equations, sorry, and try to solve the system. Now, if I look to equation 2 and equation 3, I'll find the common one is I2 here. The current 2 is the common one. And I know for sure that I2 equal the combination of I1 plus I3. So I'm just gonna sub I2 wherever in these equations, and let's rewrite our equation. So if I want to modify equation 2, it will give me this value. Just to save the time, it will be 45 minus 55 multiplied by current 1 minus 30 I3. That's equal 0. Let's call this one star equation. Now, if I want to modify the third equation by putting I2 as I1 plus I3, it should give us 120 minus 30 I1 minus 45 I3. That will equal 0. I will name it the 2 stars. Okay? Now, here we go again. I need to eliminate one of these two unknown, the current one or current 3. Let's go with get rid of the current 3. So, what I'll do, I can multiply this one by 2 and multiply by this. Oh, sorry. This one will be multiplied by 3. Yeah, 3. And this one here multiplied by 2. But because they are both negative, negative, let's do this one as a negative 3. So it will be positive 90 plus negative 90. That's it. It's done. So here I can say I3 is out. Done. Now that will leave us to calculate how much is the current one. But to do that, we have to solve this system. It will give us by you're just gonna do 3 times 45 minus, then you subtract that from 240. It will give us 105. Same with the minus 3 times minus 55. It's a positive 56 and minus, yeah, that will give us again and positive 105 I1 equals 0. So from here I can find that I1 equal minus 1 ampere. That is the value of the current one, or the current going through resistor 1. Okay, now simply you're just gonna take this value minus 1 ampere and you can use it inside one of the two equations, star or double star, okay, to find the current 3. Or you could go and use it with equation number 2, the top one in the yellow, to help you find the second current. Then you can find 3. It's up to you which one you want to use, but from the calculation I did before, you should end with, we said I1 is a negative 1 ampere. You should end with I3 equal 3.34 ampere. And as I said, I2 equal I1 plus I3, that's at the beginning, which will give us 2.34 ampere. And it's positive. So these are the values of the 3 currents going through this circuit using Kirchhoff rules. Step by step, maybe I'll try to do this example faster compared to the previous video, so you can practice by yourself more and build your confidence. I hope you like this video. We'll see you again. Thank you.